Hi folks, this is Nikhil and you are learning GOlang with me. In this session, I am going to explain how to create a simple web server in GOlang. And this will be a start of our series on how to create the REST services, how to create the web server, how to create the multiplexer in order to have the production ready, production grade web server in GoLang. So let's get started. So one of the important thing that I want to emphasize on at the start of the session is today you cannot live without the HTTP and REST request or today's new modern way of handling the web services or the web request is gRPC with protobuf. So in order to be there in the market, in order to run your business online, you require to expose your APIs, you require to be online, and the best way to do so is having the REST services or exposing your endpoints so that others can make use of your services. Whatever business you are doing, whatever the functionality you are providing, that functionality gets consumed and you get the money in return. That's the whole goal, right? That's why you are in the business. So in GoLang, this was the foundation. So starting from the scratch, the founders of GoLang actually focused on this particular area, that HTTP and HTTP2 or REST or even the web services, web server, all of these are important parts of the business, parts of the programming language, and that's why they have given so much of attention to make the resilient web server or to make the resilient REST services in GoLang. So there are many ways to actually write the multiplexer, to write the server, web server, to instantiate and run your REST service. We will start from the simple ones, and then as the series grows further, I will start focusing on the multiplexer, the Gorilla multiplexer, or the others, and then slowly and gradually we will move towards REST services, then production grade REST services, then towards the gRPC with protobuf, and finally I will demonstrate how to use the containers and expose your services in AWS or any other cloud, and then finally the service mesh will get into the picture, in which I will demonstrate how to make use of ingress, Kubernetes ingress, so that you can control the traffic and other things as well. So if you navigate to the net HTTP package, you will see many of the functionalities of the HTTP or web world implemented in GoLang. So a lot of the stuff already exists, and I have played with many languages so far in my programming life, be it Java, be it Scala, be it Python, be it C++ or C. However, I must have to admit that in GoLang, the simplicity is one of the crux, is one of the foundation of GoLang. You can just write couple of lines of code and your resilient web server is ready. So that's what I'll be focusing on in this particular session. So first simple way to create your web server is to implement the interface handler. So if you go to the HTTP package, if you go to the server.go, over there you will find the methods that deal with the TCP. So what is TCP, right? HTTP works over TCP. So you create the connection, and you as a server you listen for the uh, request. So HTTP is the request response protocol. So unless and until client hits the server will not be able to initiate the connection. It's not a WebSocket, right? So WebSocket, it is a bi-directional channel, whereas HTTP is the unidirectional channel. So you create the request, and in return you get the response. That's how it works. So in the server.go you will find a handler as the interface. So if I check for the handler, then um, you will find that handler is the interface and it has serve HTTP as the function. It accepts two parameters. First one is the response writer and the second one is the request. So you can see the description that a handler responds to an HTTP request. Serve HTTP should write reply headers and data to the response writer and then return. Returning signal that the request is finished. So it's a blocking protocol. It is not valid to use response writer or read from the request body after or concurrently with the completion of the server HTTP call. What is response writer and request? So if you see the response writer interface, again it is the interface. So the thing is, you can have different implementation of this particular interface. A response writer is nothing but whatever the response that you are sending out, for that particular response you have the object which is the response writer. So you can set the HTTP response header, you can set the HTTP response body as a part of this, and the second one is the HTTP request itself. So if you see that, then it's a struct and there are many attributes of this particular struct. So let's see the documentation part. A request represents an HTTP request received by a server or to be sent by a client. And you have the method, so either a get or post or put. Then you have the URL, then you have the header, the HTTP header, then the body, then the encoding, transfer encoding, and the other thing. So you may not have to worry about all of these attributes because not all of them are really required. We are just focusing on creating the server right now. The focus is not on the HTTP client. So if you just want to create the server, then just create this function, and then you require to attach this function to one of the type, because there are many ways to actually create your web server. So one of the ways to have the type and then to attach the serve HTTP method to that, and then once you do so, then you create the listen and serve HTTP listen and serve. It actually accepts the address on which, so the port and the host on which the server has to be started for the incoming connection. So listen and serve listens on the TCP network address and then call serve with handle to handle request on the incoming connections. Accepted connections are configured to enable TCP keep alive. And you can see that there is a default server mux is used. I'll not go into the details of this because the focus is really to create the web server, not to dig down into the details of the multiplexer and then the types of multiplexer and then the router, the GOlang routines and all that stuff. So first one is the address, second one is the handler part. The handler part is actually coming from the type, because you are attaching the method to the type, and this type, the function, the serve HTTP, if you remember, then it is nothing but the type of handler. That's the interface that the function is within. So that's why once you have this particular method and then you attach the type to that, then you automatically have the handler in hand. So let me just go back to the interface definition. So so that's the interface definition. So you just require to have this method and attach it to the response or the body or the type, and once you do so, then you can just pass the type, automatically it becomes your handler. And then if you pay the attention to the code, you just have this method, you just have the something to write. So you get the HTTP response writer. So this is the response writer that we are using, and you write the response, whatever response you want to send to the browser, to the client, you write it to the response writer. That's it. So over here we are using format fprintln because it accepts the writer, and then you just need to decide upon the port, and then once you start this particular main method, once you run it, then you will see that it is actually it is waiting for the connection, it is waiting forever. So if I go to the browser, and if I just hit the localhost HTTP localhost 8080, then you will see that this is hello world. That's what we are returning right from here. This is hello world. Now the interesting stuff over here is we are not handling any specific path. So by path I mean the URL path. You have the domain and the subdomain. So we just have the basic fundamental. You can have any path like this. The path variable in case of the REST service, or other things, the query parameters, all of these things are not really in question over here. I can pass anything because for the web server there is only one handler. All of the requests are going over there. There is no multiplexer defined, so there is no router defined. So that's why only one handler is there. So this is a very basic handler, the very basic HTTP request. But at the same time, if you are the beginner, then this is the best thing to deal with. This is the best thing to start, because it does not really require to have more than three lines of code. That's it. So this is the first one. The second one is to create our own web server with the additional parameters. And for that I will be using another method of making use of the handler. So now if you see this particular implementation, you have the handler, and I'm creating my own handler. So I just need to have the function. I don't have to attach it to any specific type. I just need to create the function. So the first type is creating the handler instance. Second type is using any handler func. That's what we call it in GOlang. So any handler func is okay. So you create the function, you have these two parameters as the input, and then that's it. And then you use HTTP handler func. It accepts the any function that has two parameters, response writer and request. That's it. And once you create the handler, the second step is to create the server. So over here I'm creating the HTTP server. So you can see that a server defines parameters for running the HTTP server. This is your own HTTP server. Whatever the parameters that you want to specify, these parameters will be specified. If you have experience with playing with the Tomcat, with the WebSphere, with the WebLogic, then Tomcat is the web server, right? Apache HTTP is a web server. Tomcat is the application container, a bit more than the HTTP server, but at the same time, the initial focus of Apache Tomcat was onto the HTTP server. WebLogic, WebSphere, those are the best used for deploying the enterprise level applications, EARs and enterprise archive files and web archive files, WAR and ER files. However, in GOlang you do not really go to that level because of the different things, and you can handle these things as a part of the simple service. Java's world is a bit different, and that's why WebLogic, WebSphere, this come into the picture. Now you have the HTTP server, you have the address, you have the handler, you have the read timeout, you have the write timeout, and you have the max header bytes. Now as a part of the read timeout, write timeout, you can define your own values. Over here the important aspect is the address and the handler, and then I will just close this. So and then finally you just get the instance of the HTTP server. So I will say this is my HTTP server instance, and then I will say that listen and serve. And once you have this in place, you start this on 8081, so there is no clash with 8080. You can see that both of my programs are running, and again I will open the same path. Only the difference is 8081, and you can see that hello, you have it the path, because the response that I am sending from my handle request is different. So you have the response as hello, you have hit %s from the request I'm extracting, I'm retrieving the path, the URL path, and that's what I'm returning. So I can use anything over here. And yeah, because as I have not specified any handler that accepts the path to looked upon, that's why I can actually respond to any of the requests. Now, important thing over here is to note that now in our handler function there is a capability to identify the path for which the user has requested for. So then our next step is to create the router, is to create, have the multiplexer, and then you can now imagine how I will be taking these things forward. So once you understand these two aspects, one is having the HTTP func, and then second is implementing the handler interface. The third one is to specify the path for which we have a specific handler. Now this is absolutely important, because just imagine any enterprise level application. If you just want to have a very simple application, then most probably you will have the one URL and that's it, because maybe you just want to push the content to your web server, that's it. Maybe it's single, only one page application, not single page application, because there is a single page application as well, which means that the URL remains the same, page is rephrased, the whole page is not rephrased, only the few parts are rephrased. So there are many things that are coming, that have already come and have matured in the front end or the UI, user interface. But you can see that behind the scenes there will be different URLs, or in case of the REST also you will have different REST path, and then depending upon the path you would like to route your request to a particular handler. That's what we will be doing as a part of this last demonstration of this session. So again you have the handler, but this time around you don't attach your handler to the server. You don't give that handler in the server. Instead you just say that HTTP handle, and then you give the pattern. So what is this HTTP handle? Handle is to register the handler for the given pattern in the default. Forget about the mux. So whatever the path that you will be giving over here, so for example this one, so so whatever path you will be giving over here, automatically the domain will be, so the host name and the port, so all of this will come from the address. And then you can have the API router, sub router, all of those things. You can have the nested path, but we will see all of this in upcoming sessions. Right now the focus is to specify the path and specify the specific handler for this. So let's say you have got a specific handler for a path. So now you can see that in this handle specific path, again we are using the same input parameters. Again I am using a printf, but the magic will begin when I will start the web server and then hit the URL. So let's say if I start the web server and now instead of 8.1 I will say 8.2, now you will see that I am not getting the response. I'm just getting 404 page not found. So it means that my web server is there, it is running on 8082. At the same time there is no way for that web server to handle this particular request or path, because this path this path does not exist in my web server. So web server, when it tries to find the route, it will not actually find it will not able to find the route for the path. So what I will have to do is I will have to take this path, and then after the 8082 I will use this, and then now once I hit this path you will see that hello, you have got a specific handler for the path. So I can specify many handlers like this one, and I can come up with my own pattern and then handler. Only thing to remember is you cannot have one handler serving one path and multiple handlers. So okay, one handler can serve multiple path, but one path cannot be repeated again. So you can see that behind the scenes what's happening is you have the handle, it is the registry, it is nothing but the registry. So you have the defaults or marks, it goes to the handle, then you have the pattern. So if I search for the pattern, then you will see that there is a mux entry, there is a lock, all of this process. Mux m is nothing but the map of string of mux end. So now you can see that server mux, it is a type of, it is a struct. Inside that struct you have the string, which is the URL and or the path, and then mux entry is nothing but the handler. So you can see that h and handlers. So because of this you cannot repeat the one URL getting handled by the different handlers, because it's a map, right? So and obviously it makes sense. So now you can see that if I change the path, let's say new path, then if I restart this, then you'll see that if I hit my path, I don't get the response. Now if I go to the new path, now you will get the response. So that's how easy it is to create the web server in GOlang. And let me tell you that this is very production ready code. So if I just add it in my production without the router, without the mux, even in that case it will provide very high availability because GOlang is very robust. So that's it for now. I hope you have learned something from this session. If you like the session, then please subscribe to my channel. Thanks for listening to the video. That's it for now. See you in the next session.